All right, so we are talking about the Pythagorean theorem and how to apply it to more than just when you're given a right triangle. So when you have the Pythagorean theorem, right, we know the Pythagorean theorem is a squared plus b squared equals c squared. Yes, we know that. We understand the Pythagorean theorem. It can be more than just for a right triangle. One example of that is finding distance on a graph. And so we're going to deal with that today. We're going to be finding the distance of 2 points on a graph. Now, let's say I have the point right here, and we'll say right here. So here we have 2, 5, and here we have 6, 2. I want to find the distance between these 2 points. And I want to find this line that goes in between those 2 points. Now, I am going to be looking for the change in my y value and the change in my x value and my y value. Now I can say my x value change, this can be side A, my y value change can be side B. That makes here my total distance side C. If you remember from a while ago, we talked about how to find vertical change and horizontal change. Vertical change, so our vertical change, our B, is going to be the difference in y2 minus y1. We take our y from one point, subtract our y from our other point. That gives us the total distance. Our change of side A, our horizontal change, is going to be the same with x. x2 minus x1. How far x is over here compared to how far x is over here. That's going to give us our change. All right, so using all this information here, we can come up with a formula. We'll call it the distance formula. The distance formula to identify how to find the difference in 2 points, how far away 2 points are from each other. So if we have the, don't want that. We want to know the distance. So if you remember Pythagorean theorem, a squared plus b squared equals c squared. And c happens to be our distance we're looking for. So we're looking for c. Now, in order to solve this, we can say, all right, well, let's square root this and square root everything over here. This gives us c equals the square root of a squared plus b squared. All right, this equation right here will always give us the distance we need. But when we're on a coordinate plane, we don't necessarily know what a and b are. We need to solve a and b. We actually did that up here. So instead of a squared plus b squared, we can say c equals the square root of a was x2 minus x1 squared plus b was y2 minus y1 squared. And so this right here is our distance formula, okay? And I know it seems like a lot of symbols and letters, and there's some numbers in there, but they're not actually really numbers. They're like weirdly numbers. It's a lot of information, but we're going to break this down so that you understand how to use this formula to find the distance between 2 points. Okay, so let's say I have these 2 points, 2, 5, and 6, 2. Now let's use those and plug that in. We'll call this point 1, we'll call this point 2. For no reason, it doesn't matter which one is point 1 or point 2. I don't care, but we will use this information to help us know how to plug our information in. Okay, so C equals the square root of a squared plus b squared. Now to find the values in a, we go What's our x of 0.2? Well, our x of 0.2 is 6 minus, what's our x of 0.1? 2. Okay? What's our y of 0.2? Well, that's 2 minus, what's our y of 0.1? Well, that is 5. Okay, so I've plugged all the information in to my formula just by using the 2 points. Now I know I have the 0.25 and I know I have the 0.62. Now I'm going to simplify this. C equals the square root of 6 minus 2 is 4 squared, plus 2 minus 5 is negative 3 squared. Okay, now let's keep working through this. C equals 4 squared is 16 plus negative 3 squared is 9. C equals 16 plus 9 is 25. C equals, and the square root of 25 is 5. Our distance between these 2 points is 5 units. I know that seems like a lot of work. It seems like a really long time to get to that information, but that's what it does. That's the work we need to do, and the more we practice, the more we get into it and make sense. That's the work we need to do to solve these equations out. All right, so I'm going to erase all this. We're going to rewrite our distance formula. We're going to work through another one, an example to show you how this works together. All right, let's go back up here, get rid of all this. I don't actually need this information either anymore. Now I just need my distance formula. So we've learned 2 main formulas this chapter, the Pythagorean Theorem and the distance formula. Okay, our distance formula was C equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Write this down. Make sure you have this information. All right, let's make some new points. Let's go with a, here we have negative 2, 3, and we'll go here with a 4, negative 5. Okay, our 2 points here are negative 2, 3, 4, negative 5. All right, now let's plug this in. We'll call this one 0.1 and this one 0.2. Let's plug this information in. C equals the square root. x2, the x of 0.2 is 4 minus the x of 0.1 is negative 2 plus the y of 0.2 minus the y of 0.1 is 3 squared. All right, now let's solve this math. We'll go C equals the square root 4 minus negative 2. Minus negative is the same thing as positive. 4 plus 2 is 6 squared plus negative 5 minus 3 is negative 8 squared. 6 squared is 36 plus 8 squared is 64. 36 plus 64 is 100. The square root of 100 is 10. The distance between these 2 points is 10 units. Okay? I didn't have to draw out any of my triangle because once I have my formula, I don't need all this information. I don't need to worry about that. Once I have my triangle and I know my points, I can identify what is the distance just based upon 2 points given to me on a graph. As long as I know my distance formula, I can find the value of any 2 points that are given to me on a graph. That's one thing we're doing today. We're doing 2 things today. That is one of them. The other thing that we are doing today, the other place we're going with this is we're going to identify, all right, is some numbers, do they make a right triangle? Okay, so our other thing we're doing with is, what in the world is this a right triangle? Is this a right triangle? Okay, we're going to be given 2 or 3 numbers, and we want to say, do these 3 numbers make a right triangle? So we're going to have maybe 5, 8, and 12. Say, do these numbers make a right triangle? Now, these are all lengths to my triangle, and I want to see these lengths to see, is this going to work for me? Now, the first way I'm going to do that is I'm going to use the Pythagorean Theorem. A squared plus b squared equals c squared. I'm going to remember c is always going to be my biggest number. C always needs to be my biggest number. And then a and b, I don't actually care about my other 2 numbers. I don't care which one is a or which one is b. It doesn't matter. I'm just going to plug them in. So we're going to have 5 squared plus 8 squared equals 12 squared. And we are testing this. Then we solve it out and see if this is equal. 5 times 5, 25 plus 8 times 8, 64 equals 144. 25 plus 64 would be, what, 89 equals 144. This is not a right triangle. Since this is not equal, it's not a right triangle. If they were equal, it would be a right triangle. But since they are not equal, it is not a right triangle. All right. Is this a right triangle? Do the numbers 8, 10, and 13 form a right triangle? Let me know, and I will see you all next time. When we talk more about this, get this done, and get working towards our test. Bye.